Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast brought to you by Nutrien Ag Solutions. I want to spend a little bit of time at the beginning of our forecast video today discussing the event that happened over the weekend in the Pacific Ocean. I'm going to show you an animation here. This is from a satellite called Himawari 8, capturing the eruption of the massive underwater volcano here in Tonga. And as you can see here from this animation, let's watch it one more time. The amount of debris and ash and soot and other gases and aerosols ejected deep into the atmosphere here likely extended several thousands of feet into the stratosphere. If we look at it from a little different perspective, I want to make sure you know where you are. So this would be the east coast of Australia. This is New Zealand. And we're very close to Fiji when we look right into this area. So now as we play this animation, you're going to keep an eye right there, and you can see that the powerful blast from this just absolutely massive volcanic eruption. Caught it on infrared as well. This is from Goes West. Again, we're going to keep an eye right here on the eruption. And it's maybe a little easier to see in this animation a couple of things. One, look at how deep and how spread out into the atmosphere that ash plume became. You can also see how cold those cloud tops are, suggesting, or the ash plume is, suggesting this got deep into the stratosphere. You can also see the shock wave that was sent out from this, and that shock wave was felt and measured all over the world. This was a sizable blast. Now, it was heard as far away as Alaska, which is way up here in the corner of this image, and certainly heard throughout all of the surrounding islands, and Australia included. Now, the Bureau of Meteorology out of Australia released a great figure to kind of show you how that shock wave went across Australia from the eastern side to the western side here. And what you're looking at here is the shock wave as a change in pressure. Now, a 6.9 hectopascal, that's a unit that has the same magnitude as a millibar, okay? A 6.9 millibar shift in pressure like this, not only will it be heard and felt, but you'll also, out of this, your ears will pop. But the reason why you see the disruption kind of staggered is because it takes time to cross Australia, and it did so in about 4 to 5 hours. That's how quickly it made its way across Australia. Just impressive to see that. Now, in addition to this, this particular event produced a tsunami warning, across a broad part of the Pacific Ocean. But I want to just show you what we saw along the west coast. NOAA released a report that suggested that all along the west coast, tsunami depth was between 1/2 foot and up to 5 feet. In parts of California, hit over 5 feet. This was the wave that came into parts of Oregon. Just impressive to see that. And again, this was here on Twitter where we saw this. So I want to thank some people here for posting this so we could take a closer look. Now, speaking of the tsunami, there were a couple things about this particular event that just baffled me, and I got to show you one of them. And it was this guy right here. You just watch. I don't know what's going on, but this guy decides as the tsunami is approaching to kind of get in a fight with this tree. He's prepared. He has his life preserver on, but you can see the other people running in the bay away from it. And here comes the wave, and they're all trying to get pictures and videos of this. So then the tsunami wave comes in and just takes him over, and then that guy clings for life to the tree he was beating up on, which gets knocked down, and these people all get kind of swept away. I'm just going to make a statement here. This is not what you do in the event of something like this happening. Okay, here's probably the more important discussion we have now that the event has finished. This is a picture from the eruption of Mount Pinatubo, and that was in the Philippines back in 1991. Now, the reason why I come back to this is I heard a lot of rhetoric over the weekend comparing the two volcanic eruptions. So let's do that so we have a better understanding of this. First of all, Pinatubo erupted in June. It was a 3-day eruption in June in 1991. This eruption out here in the Pacific, of course, was in mid-January. When we think about Pinatubo, we often compare it to some of the biggest volcanic eruptions we have in history now. This data set only goes back to 1979, and we're going to look at it in a couple of different ways, but remember, this doesn't include some of those massive volcanic eruptions like Krakatoa back in the late 1800s. But the size of each circle, okay, references how much sulfur dioxide was basically in the mass of the ash plume. And then we can see how high the plume went in altitude by the color coding. So the stratosphere begins roughly somewhere between 10 and 12 kilometers, so you can get an idea that some of these made it very deep. Now, this does not include the most recent eruption, but it does have, of course, Mount St. Helens, which is here, and St. Helens, pretty large amount of sulfur dioxide put into the atmosphere, but nothing compared really to, and I'm sorry if I say this wrong, I looked up dozens of pronunciations and they all were different, but El Chichon is how I might say it. This one here, it did put just a tremendous amount of sulfur dioxide in the atmosphere. Maybe the biggest on the list, though, was Pinatubo, the one I showed you, where you can see its value compared to all of these other volcanic eruptions we have in this 42-year time series. Now, the reason why we care so much about sulfur dioxide as a gas in the stratosphere is once in the stratosphere, it can stay there for a while. It's statically stable, and therefore there's not a lot of mixing, so therefore gases put into that layer tend to stay there. And why we discuss that, I'm just going to take you to a paper published in the Review of Geophysics. This was from a person that published this out of Rutgers University. And this is the main idea. The apparent transmission, we can also think of this as optical depth. This is how much of the sun's light is extinguished by the gases in the atmosphere. Well, when El Chichon erupted, and then when Pinatubo erupted, we saw substantial decreases in direct sunlight because of all of the gases in the upper levels of the atmosphere, the sulfur dioxide specifically. And this is what's neat about it. Whenever you increase the amount of sulfur dioxide in the stratosphere, like we did here in 1982, that was El Chichon in Mexico, and then Pinatubo in 1991, you get a lot of stratospheric warming. And stratospheric warming leads to tropospheric cooling. Okay. Now, why this is important is there's a lot of questions and discussions about what we got out of the current volcanic eruption. And right now, this is all that I've been able to measure. So I'm using here a satellite on board EOS Aqua. It's called MODIS. There's actually two MODIS instruments up there in space. One is on EOS Terra, the other one's on EOS Aqua. And we're looking here at sulfur dioxide in the upper troposphere and stratosphere. Now, what we know to this point is the amount of sulfur dioxide that has been put into the stratosphere at this point does not yet compare to what we saw in Pinatubo. Now, that's what I'm trying to tell you. Up to this point, current knowledge, what I understand is that it's not. This area we're going to need to watch to see if it expands, if there are future eruptions, and what else gets up there. Now, the reason why we come back to this all has to do with the way that sulfur dioxide affects the transmission of sunlight and its eventual impact on temperature. So I'm going to take you to one of my favorite sites, NOAA's Climate at a Glance. We're going to look at a national time series of average temperature for the whole year going back to 1895. Now, when you look at this closely, 1982 is the first year we want to investigate, and 1982 is here. Now, what you notice is that the following 3 years after 1982, we did see that the temperatures really resisted big spikes up. It wasn't that they were cold, all right, but in other words, it wasn't also years that followed El Chichon with very hot conditions. And then in 1991, in June, right here, when we had Pinatubo erupt, you can see that the next year and the year after that, and even the year after that, all had, they didn't have massive spikes upward in temperature, which means we expect if there is a large volcanic eruption that puts a lot of sulfur dioxide into the stratosphere, possibly a 0.5 degree to a degree Fahrenheit cooling in the subsequent year. That's what that says. But do you see how both of these events still fall kind of within the noise of the overall temperature patterns we've seen annually since the 80s? So I want to stress that very carefully here. I also want to say this. You might hear a lot of people talking about 1993. Now remember, in 1993, we had extremely wet conditions. And those very wet conditions led to, pretty sizable, look at this, yield loss. Now, some people have just been kind of freely associating 1993's flooding with the Pinatubo eruption. And I spent some time searching over the last couple of days for peer-reviewed journal articles that suggested that Pinatubo's eruption played a kind of a high-order role in the floods of 93, and I cannot find that. I also want to show you this. Now remember, Pinatubo erupted in June, all right? So what you see here is that 1991, this is corn yield, by the way. We were off trend by, 7 bushel or so. But 1992, the following summer, was above trend by about 10 bushel. So overall, we cannot use this one event to assess what next year in the growing season, or excuse me, later this year in the growing season is going to look like. And I just chose the Corn Belt, but I could have done this anywhere across North America. Plus, remember, this was a Southern Hemisphere event, so we have to see the impacts of this spreading into the Northern Hemisphere first. So I guess if I had to put a concluding remark on this event was absolutely massive, but we don't yet have evidence that it's going to have a climatic effect. And that's why I think the most important story I can deliver to you about this is going to be. All right. From there, where are we headed? Well, I thought we'd talk just a moment about snow, because the weekend system that pulled through parts of the Mid-South and then headed up into parts of New England added to this map. So again, we saw upwards of, some places here picked up 8 to 12 inches of snow in Iowa, and that whole snow band just kind of came down like this. The system curled and ran up the East Coast. It's still going up the East Coast today. But the map you're looking at is total accumulated snow so far through January 17th. Now, we have huge amounts in the mountains in the west, 100 to 200 inches here. Okay, and when you get up here into the northern plains and upper Midwest, we're well above 40 inches so far. So this is a significant deviation for this area compared to last year, especially North Dakota. But just take a look at this. There's an interesting area right in through here. It comes out of parts of Missouri, Illinois, Indiana, and far western Ohio, where we've got this just hole where we have yet to get a system coming through to produce some snow. There's been more snow in Tennessee and Kentucky, the Appalachian Mountains, than we've seen in those particular areas. We can also look at it like this. What's the departure from normal? And again, you can see that there are several places here running pretty sizable deficits. But I think we're going to continue to see some changes in this map as we go forward. And some of the places that are blue, like right down in through here, I think we're going to get bluer, especially in parts of Virginia and North and South Carolina. I want to talk about that. First things first, though, our system that we watched all weekend is finally, look at the satellite animation here, finally exiting through New England today. It did produce a lot of snow into this area. In fact, let's go take a look at that real quick. The site I like to get this from and where I made those maps comes from NOAA. And let's just look at the 72-hour total accumulation. In fact, let's blow that up so we can see it even better. There we go. So this was what we had through 7 a.m. this morning. All right, you can get a good glimpse here at those snowfall totals. Now, what's getting added to this before we discuss the long range is, by the end of this next 7-day time period, we're going to be talking about a clipper that rolls through here, produces a front that gets dragged through parts of the Mid-South over toward the Appalachian Mountains, which then becomes a low that runs up the coast again. And so all of this is all new snow here and new snow here from these next two systems. Notice the west, though, with the ridge in place, we're not adding a lot of snow here. And our snow donut, our hole that's missing here in Illinois, Indiana, parts of Ohio, and Missouri is going to remain. Now, I also have to tell you this. We'll talk about this in just a moment here. There is the chance for another significant ice storm here in this area with the next system that's coming through. And I'll show you the model differences in a moment. But first, I really want to stress the shift in this overall pattern that we might be seeing by the time we get into February. Now, I just left the map here on February. And you see that there's a large ridge pushing up into Alaska, but the trough action is coming now into the west. And there's some sense of higher heights, which means the flow's got to turn to get into that. Now, you all know this, right? If there's a trough in the west and the flow comes around, we go over very active in this area. Lots of low pressure systems and snow in the west and clippers. For the United States, a trough that extends in this area is the most active pattern we could get, especially if you add in a subtropical component to the jet stream. Now, we're not going to get there right away. That's at the beginning of February. Where will we be at the end of this week? We're going to be here. See, that ridge is too close to the west. So it's warmer and drier. And this trough, well, it ejects out here into the open ocean. So there's lots of cold air coming into this area, lots of it. But that pattern shift, again, this pattern shift is what I want to talk about. Now, how do we put together what's going on here? First, I'm going to talk about the tropics. Now, if you look at this, do you see how there's kind of a column of these blue-green colors sitting right over phases 6, 7, and 8 as we go forward from today through the next 15 days? You don't see this graph and see any sort of like a horizontal translation to the east, and we're looking here at the MJO. Some of the newest data from the MJO, from the long-range models, suggest that, okay, it made a brief run into phase 8. It's now into the null space, okay, which means we don't have a strong signal, but it pops back out and wants to come back close, I think, to phase 7. Now, after that, there's a mess. So we're going to leave it at that. It's going to come back out into phase 7 by the end of this month. And I've now shown you this a lot. Phase 7 is key to see that ridge move and migrate west or toward the Aleutian Islands. That'll take this trough, see it here, and move it a little bit west too. That would re-engage the western part of the United States, not California unfortunately, but most of the west with more cold air and snow, and give a very active pattern coming through the Ohio River Valley and also Clipper systems staying in that colder air. This all comes together in the northeast. That's what we're watching. This is a very active setup if this all just retrogrades a bit to the west. Now what helps it along is the fact that we have this La Niña that's still a bit east focused, and this cold water here helps push all this in that direction as well. So there's a couple of pieces working in favor of all of this moving west. We also look at our total, our zonal and vertical integral of atmospheric momentum. And the loss of momentum here, but the increase here, which is the end of our La Niña, and the increase north tells me that this retrograde, especially this loss of momentum here, is possible in this pattern. So what do we end up getting out of it? Brand new, just released this afternoon. This is the European weeklies. We're looking at the entire month of February. And now we see where the drier conditions are. We see that coming into the mountains in the west, better snows. We see that near normal precipitation coming out of the Canadian prairie, and then systems, those clippers coming across the Great Lakes into New England, and then right in through here. That's the area that's going to likely be very active. That's very consistent with the cold water over there by South America. And overall, this is just a continuation of the forecast the ECMWF put together for February last Friday. What I do not like about it is this is not the type of pattern that will be corrective on the drought issues that we have in Texas, Oklahoma, Kansas, New Mexico, and Colorado. It is corrective on the drought issues we have in the Mid-Atlantic. We're going to continue that as we go forward. And the temperature pattern over the next 30 days, this signal toward mild here means that we're going to start to see several, probably those downslope wind events where we bring in the compressional warming, the very low humidities, and this is going to hit the southern plains, I think, more often than not. We carry a cool bias from the Canadian prairie into the Midwest and into the East Coast, almost the whole of the East Coast here. So this is a very important long-range forecast the European just released here for the whole month of February. All right, expect a lot of activity, Ohio and Tennessee Valley. Now, in the near term, we've got to watch what's going on just here with the next Clipper system, because that's going to be the trigger. So first, this was our system midday today that's exiting New England, and that's the one that produced a lot of snow. Got some cold air and some lake effect behind it in the overnight tonight, but our next Clipper is rolling right here through the Red River Valley of the North. The snow is on the northern side of it. Throughout the day on Tuesday, that system pulls through the Great Lakes and hits Ontario, and then it ends up right here by the time we get into Wednesday midday. Now it's going to leave a front in this area, but there are winds coming out of the south running right over the top of this front. And watch what you end up getting out of it. There's the potential in this area for a band of freezing rain as we get into late in the day on Wednesday. And you can see that with this high pressure cell that's coming in behind it, there's going to be just a lot of very, very cold air coming in behind this. There might even be a changeover for snow, parts of Missouri, Illinois, and right here along the Ohio River, and a mixture of sleet and freezing rain here before we get to rain to the south. And that front, by the time we get out to Thursday at midnight, okay, so this is Wednesday night to Thursday morning, is just progressing slowly with a lot of very shallow cold air on the backside. That's what's giving us the overrunning. What I want to do next is I want to shift to our multi-model analysis, but I want to talk first about this. You know how I love to compare the GFS and the European. But I need you to know something, and this comes from my good friend Ryan Maui. He actually puts together a skill score for the models, and I've shown you this in the past, but I want to make a point here. Lately, the GFS has had some problems. The European has been pretty steady, but the GFS, throughout January, its skill score has dropped off tremendously, and you can see the differences. Now, why I want to illustrate that point is because when we do this, watch how quickly the differences show up. So 12Z GFS on the left, 12Z European on the right. Now we've already seen that first system and the second one that goes right here across the Great Lakes. I'll show you those snowfall totals in a moment. In both models, by noon on Wednesday, there's a frontal boundary that's picking up on the precip. This is consistent through the next 54 hours. Now what's interesting after that is how we get into the day on Thursday. They both show by midnight Thursday, the position of the front advancing east. See this? Now watch the model separation. Big highs in both cases, in the same places essentially, although the European is farther to the south. So what ends up happening here is as you go to noon on Thursday, 6 p.m. on Thursday, then we get into midnight, 6 a.m. on Friday. Okay, look at the differences. All right, they both introduce another system in Montana, North Dakota, parts of Saskatchewan. It's there. But what's happening over here is that the European model by Friday morning is putting together an ice storm on some cold air damming, on some very shallow cold air coming in behind this big high pressure cell. Now, as we go forward, look at that. This is 6 p.m. Friday. The model, the European, is starting to pick up on the development of a low. What happens in the GFS is it just clears the front all the way to the coast. And the low starts to form here, and we're going to get some really possibly a dangerous situation here with the overrunning. Shallow cold air coming from the north, warm air just above it running right over the top, just like this. So what does the model do? Produces more snow in eastern Kentucky, really eastern Tennessee, maybe northern Alabama, northern Georgia, and then into North Carolina and Virginia. That system goes. Look at this. Now, what does the GFS do? Okay, agreement here. But the GFS then takes another shortwave that's coming out here over the Gulf and turns that into the next system. So while the European, its first system, is now here running through New England, the GFS is late to the game with an entirely different wave that produces some ice in that same area, and then it tries to spread up the coast but just doesn't get there. I'm only 150 hours into this forecast. This is Sunday at noon, and the separation is quite substantial. What we do know is after that, we're going to see clippers kind of running through this area. So both models at least agree on that. See, a clipper comes in here. Wow, how does it get these two waves right, but have the other two wrong? That's a very interesting scenario. And then it even tries to bring in this one here in the GFS, and maybe it's a little farther south here in the European, or west, excuse me. But we're seeing that happen, and another big shot at some colder air that's coming through. So the model I'm going to pick because of the skill score is the European. So this is what it's doing. Through Wednesday into Thursday, Friday, this is Friday noon, Friday afternoon, Friday night, Thursday morning, Saturday morning, Saturday at noon, Saturday evening getting into Sunday. And you can see that we need to keep a very close eye on this area. It's in the ensembles as well, that we need to watch this same corridor, which was hit earlier in the month with some heavy snow coming again. Who's missing all of this? You can see it's that same donut hole here with our clippers still going to the north of it. Now, I am concerned about the icing threat. And if you just look here, I'll take you back. It's going to be Friday morning through Friday evening. That's the time period in this area that right now I'm most concerned. Now, between now and then, my daily updates will cover the changes, and I'll give you another video on Thursday about this, and we'll, of course, have a much better picture at that point. But I'm watching this part of the southeast into the mid-Atlantic very carefully right now. Now, to show you what's going to happen by 6 a.m. on Friday, this is the freezing line. See it? So there's warm air warm air in the low levels of the atmosphere, but the surface temperatures are brutally cold. And throughout the day on Friday by noon, we don't see a warm-up here in the model. See that? That's why we see the threat for the freezing rain throughout the day on Friday in the Carolinas and back over toward parts of Georgia. Details will emerge this week about that setup. But if I told you how much precipitation was falling, this is what the European model has. Let's zoom back in there. Total precip through the next 7 days, liquid equivalent. And what I want to illustrate here is who's not getting this. So the West Coast with the ridge, parts of the Midwest are going to be dry down to the Southern Plains. All the action is really setting up on that front that then turns into that system that eventually rides up the coast. And there's our clippers. That's your rundown for this week. Let's get into that week 2 forecast. By day 10, trough is here. That's why we stay dry in the convergent part of this trough. But watch, through day 12, 13, 14, into 15, 2 runs of the European model push the ridge toward the Aleutians. That's what we saw with MJO Phase 7 helping out there. Trough digging in here, going into a very active beginning of February in this area. More snow in the west. Now the models aren't there yet because this forecast right here, week 2, ends on January 31st. So this means that maybe getting into that week, we still remain dry. This is week 2. It is after that things are going to pick up in a big way. All right? Temperatures, and then we'll wrap this one up. This is what the month of January's look like right now. Major shift from what December gave us. We're looking at temperature ranks by climate district, much, much colder across a broad sector of the United States. And as we look at those temperatures here, we've already seen these temperatures today, very mild in the plains. But watch this. By the time we get into Tuesday, big open area of warm air here. That's a lot of downslope and westerly winds. And then what we see is by Wednesday, the front drops through. It then pushes east with some brutally cold air here by Thursday in the middle section of the country. And that keeps going on Friday into Saturday to the east. And we're not done yet with these plunges of colder air. Montana might have the most volatile temperature pattern of all locations because they're going to keep getting these shots at cold air coming through, followed by big warm-ups. Because this is what the GFS ensemble and the European looks very similar, where we're going to see day 5 through 10. See that cold air still occupying this side of North America, and now here even day 10 through 15. Now what will change with this is as we get into the month of February, I expect more ridging here. We're going to see some mild days coming in because the flow is going to come over a ridge, dive, and then eject like that. So we're going to start to open that Gulf back up, meet this up with some very cold air that's been in the Canadian prairie, and in between we're going to really see things pick up. One last thing to talk about, let's just go quickly up here and take a look at what's going on with the polar vortex. Still quite steady and quite strong. It has moved a bit farther, kind of to the northeast, if you will, here, but it's still sitting over the Arctic, and right now the forecast is for it to remain relatively strong. No disruptions predicted as of yet. So with that, I'm going to wrap it up, and we'll keep watching this so we can report back to you again on Thursday. Thanks.